Hey, it's Mr. Tush. We're going to have a conversation about the January 23rd homework, just to review how that went. So you can take a look at this not only now, but back at the when you're studying for your AP exam. So let's take a look at how we did. Most of you got this one, but I did find it tricky. Just one of the things to be aware of. Sometimes they give you three options, and then they actually, all three options are correct. And this is one of those times. Only a couple of you thought this was the correct answer, but this whole thing about using simulation software to save money because you can compare designs early in the process is actually one of the primary reasons they make prototypes. So just be aware of that's why they use computers, simulations, and prototypes for that purpose. The next thing, take a look at this one. A lot of people got the round off error versus the overflow error. It's tricky. But the question is 3 bits to represent integers. Now we're dealing with decimal or base 10 values of 5 plus 3. 5 plus 3 together adds up to 8. And the answer it gave us was 0. And the correct answer is that was an overflow error. It's a little tricky to explain without visuals, so I made one for you. Let's take a look at the binary system. If you look at the question said 3 bits to represent integers. If we're looking at the 3 bits, let's take for a second these as our 3 bits. Our ones place in the binary, our twos place in the binary, and our fours place in the binary. And if they're all true, it's 4 plus 2 plus 1. And you all know that 4 plus 2 plus 1 is 7. But the question adds 5 and 3. It's a value of 8, which means I'd have to go over to here and make this a 0, this is 0, this is 0. I'd have to go ahead and kill this off. Hang on. I'd have to go in and, I'm going to get rid of this here. I'll delete it, and I'd have to kill this off and this off and kill this and move this over here, and I have 3 zeros. And now I'm in 4. And if I'm in 4, well, I only have 3 bits to represent integers, so I can't use the value of 8. That's why. Now, the next one. This one is about a simulation. Most of you understood that the simulation was not producing usable results because it doesn't have actual customer data. A couple of you thought the bank can use the simulation to investigate the two options without causing inconvenience for customers. That's true, it's just that you can't use the results. So that's why that's the correct answer. Now, the next one, a couple more of you got this wrong, took a little bit of a walk. The correct answer is a program is expressed in a programming language, which the following is true of the program. The program can also be expressed as binary code, but will be more easily understood by humans when expressed in a higher level of programming language. Now this one, a program can be expressed as binary code, which reduces the likelihood of errors. No, there's the same amount of likelihood of errors in binary code as you do any other way. Some parts of the programming can be expressed as binary code, but operations must be expressed using a higher level programming language. No, you're expressing the same operations whether you're expressing it in something like Blockly, a high level language, or whether you're expressing it in binary. It's just that it's more easily understood in Blockly, for example, than looking at strings of zeros and ones. Now, next, 6-digit binary sequences. An online store uses 6-bit binary sequences to identify each unique item. The store plans to increase the number of items it sells and considering using 7 bits. Which of the following best describes the results of using 7 bits? And the correct answer is 2 times as many items can be uniquely identified. That's exactly right, because it's everything you could identify before plus or times 2, because you have a 0 and 1 in that next item. So you have 6 zeros and ones. If you're adding a 7th, it's everything that came before times 2, the 0 and the 1 that's there. And that's why this is correct. Not 2 more items, by the way. 2 more items is not correct because that would say I could do that plus 2. And then I'd need an unbelievable number if that were the case. All right, so this one is ASCII. This is just be careful. You have to take a look at base 2 or binary number here, and you just have to do your binary math carefully. And this, honestly, H is just a math error. Somebody came up with 72 out of that, and the correct answer is 74. So that's just a little math error. Be careful. This one's tricky. But I think we just forgot how to think it through. It looks like 4 of you just didn't quite think it through. The best way to do something like this when you have binary decimal and hexadecimal, always go back to decimal. decimal 11. Decimal 11 is the value. Now in binary, if you do this out and convert it to decimal, because everything has to be converted to decimal, this is the ones place, the twos place, the fours place, the eights place. This right here is decimal 12. We have decimal 11 and decimal 12. Hexadecimal, remember, you get 0 through 9, and then A is 10, B is 11, C is 12, and D is 13. So consequently, this is decimal 11, this is decimal value 12, and this is decimal value 13. The correct answer is decimal 11, this is decimal value 12, this is decimal value 13. The values are from least to greatest. And this actually puts 12, 11, 13. This goes 11, 13, 12. This goes 13, 11, 12. So this is the only one that's in correct order. So I think it's just a matter of thinking that you have to convert everything back to decimal. It's the easiest way to tell relative values. You could do it other ways, but in terms of getting through the exam, that's the quickest and easiest way. This one, the algorithm below. The trick with counting coin flips, if you remember what we learned is that you really only have to count heads. If you count your heads, then the rest is a matter of math. How many tails were done, how many flips were done, etc. But count your head counter here. That will give me the expression that will tell me whether it's an equal number of heads or tails. So if I know that I had 100, if I know that I had 100 and I have 50 heads, then I know about my bias. And that's how you count your heads. Next, here. This is understanding the value of or, and a couple of people kind of got confused on the values of and or or. So, and needs both. Or needs either. But it needs either to be true. So, either A or B has to be true for and to give me true. If A and C are both true, which of the following is the AND gate? And the output will be true, because if A is true, OR has its positive. If B is true and A is true, it doesn't matter. As long as A is true, it'll be fine. B can be false, B can be true, B no longer matters because A is true. And OR has to have one or the other. And as long as it's got one or the other, this will be true. This input here will be true. C is already true because we already said that. And so therefore A is going to be true. And that's why you don't really care what B says. And those are all your examples. I hope that helps. Thanks for watching.